Yes, hello friends. So this is the video tutorial for today's GFG problem of the day. Count out distinct substrings. This is marked as a medium problem, but I think if you don't know what try is and how to use them, this would be a very hard problem for you guys. So let's see what the problem says. Given a string S consisting of lowercase English characters, determine the total number of distinct non-empty substrings present in the string. And this is just an explanation of what a substring is. Here, what the distinct substrings is basically not the starting and ending index, it is the content in the substrings. So like here we have ABA and here we have ABA, right? These are the two substrings, but these will be considered only one times because see, this ABA, if we already took, then this ABA is not distinct because the content is same. So here that is all also mentioned here. Two substrings are considered distinct if their contents differ, even if they originate from the different position in the substring. The empty substring is not to be counted, and the constraint is that s dot size or n rather is around 3000 at maximum. Okay, so that is fine. So let's run through the first test case. Let's see what are the distinct substrings we can get. So starting from this index, we can get A like this substring. Then we can have AB this substring, ABA this substring, ABAB this substring, ABABA right this substring. All of these are distinct. Now starting from B, we can have B, we can have BA, we can have BAB, we can have BABA, BA, BAB, BABA. Now from A, we if we get A, this is not distinct because this has already occurred, right? Now ABE, this also has already occurred. ABA, this also has already occurred. So none of these are distinct. Similarly for B also, for B, this already has occurred. BA, this already has occurred, and A, this already has occurred. So are sorry, all of these are not actually distinct. So we'll not consider them. So what is the total answer here? Total answer is so 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll have nine distinct subsets. How do you solve this? See, n was around 3000, right? N is around 3000. If we brute force this, so that is like for I equals to 0, I is less than n, I plus plus. Then we'll have to go to all the substrings. J equals to I, j is less than n, j plus plus. Then we'll have some like current string, that is the current substring we'll have. We'll add sj here and we'll check if sj is distinct. If sj is distinct, is distinct, right? Now, how will you do this sj is distinct check? We can maintain a map of strings that we have already seen, right? A map or unordered map or set, anything like that. We can have of already seen strings, and we'll have to check if this string or if current rather. Okay, yeah, current is distinct. So then we'll check current. So what would be the time complexity here? This and this both runs n times. Okay, that is the weirdest looking n I have ever made. N and this distinct check. See the size of the current string could also be n at max n. So that is n into n into n. That is n cube, and n cube is like 3 into 10 raised to what 3 ka cube. So that is 27 into 10 raised to power 9. This would obviously tell you. So we cannot brute force this. What we can do, the idea is same. Like see, the idea is same. We'll have to go over all the substrings. We'll do n square computation for going over all the substrings. But this, how can we optimize this? How to optimize this check? Okay, let's take this example only. Right. See, we have we'll start from this. Now we have A as a. Then we have B. Right. A. This is like kind of decisions. From A we are going to B. This is one substring, right? Then we are going from A B to A. Then we are going from A B A to B, right? Then we are going from this to A. So, okay, makes sense. This is one path. The other path is starting from B. Now starting from B, we are going from A. We are going from B to A. Then we are going from to B E, and we are again going to A, right? This is another. Now when we are occurring here A, so this we have already seen, right? This we have already seen. So this will, do we need a new tree or a new structure here? No, we'll just iterate over this thing. So we'll iterate over this thing. Then see, A is already there. Then AB is already there. Now, if let's say C was there, so this would have become AB, A, B, and then here C. But see, here we have A, then we went to B because this already is there. Then so this is not distinct, right? If that node is already there, we are not considering as a distinct. Then we go to the next node, that is C. Now the C is not there, so we'll add C here, and this will consider as distinct. So this is actually a structure of trie. So the structure of trie only. So we'll have a trie node here, which is called the root node. Then we'll go to all the nodes in the, so all the nodes, see if that node is already existing. If that node is not existing, we'll add it and and do answer plus plus because this is distinct. So hopefully you were able to understand what the basic of try is. Try is basically used when we need to search on prefix. Search on prefix, right? Search on prefix basically means that here, let's say we have a lot of strings A B C, A A B, A B C. Now we want these strings or the number of strings that are of the following pattern. So A followed star. For star basically is a wild pattern, basically meaning that any character can occur. So here this is also valid, this is also valid, this is also valid. Now we made it A B star, then this is not valid because this has AAB. So only these two, right? This is how the try gets used. Here how we are changing the implementation of try is using the second thing, that number of distinct strings, number of distinct strings, or number of distinct substrings, and number of distinct substrings, and this is nothing but number of distinct prefix starting from each I. There's a bit of a convoluted explanation or definition, but the from each I, if we start, what is our substring? I, this is our J, so this is nothing but a prefix, right? For this whole, starting from this string I to n, this J is nothing but a prefix, so number of distinct prefix, and we can calculate this by going to all the nodes and see if that node already exists in the tree. If it already exists, this prefix is not distinct. If it doesn't exist, we'll add a node there and say that this is a distinct node. Let's show you the implementation of this. It's a pretty basic implementation. So the idea for try node is that each try node will have 26 children, right? Because we are dealing with small a to z, small a to small z. So that is, so that, see, for each node, if we are at this node, so A B A, so A, then there's a B, then there's an A. Now we are at this string, so we are at ABA. What is the next character that can be? There can be 26 choices, right? So 26 different children. Now, currently, none of the children are set, so we set all of these children as none. So we create this root node, try node. Then, as I said, we'll go over all the prefixes. We'll maintain a current node. This current node is where we are currently. So when we do this like traversal here, when we were doing this traversal, let's say for starting from A here. So I'll just brute forcing I'm just showing how this would go. So we currently have this current set to here, current set to here. Then we A. So see what we do is now get this uh, get this child. So child for A, so that would be the first child of the current node. So first child of current node is set as is not null. So we'll go to it and will not update our answer. Right. So that is what we are doing. If current of child is null, so if it is null, so let's say if we were here, so we start from this index and we see C. So C is actually third child. The third child is not set, so we'll set it here. So basically what we are doing is, if it is null, add answer plus plus, go to that new node, and then add a new node and return the answer. So yeah, this works. you should like study the basics of try. If after studying the basics of try you were not able to understand drop a comment, I will like to explain it even further. Yeah, thanks for watching. Bye bye.